Welcome back to Calculus 1. We're working on problem number 7 from homework set number 5. Now in this particular problem, we need to show something, so we can't really look at a solution, we just need to look at the whole video, the whole proof.
We need to show that a circle whose center is 2, 6 and has a radius of 5 can be expressed using the following equation. Okay, so how do we do that? Well, let's draw out a picture. So we need a center at 2, 6. Okay, so there's our center, and it has a radius of 5. So that means it goes up 5. 1, 2, 3, 4, 5. Put the radius out like this. Down 5. To the right 5. And to the left 5. Okay, so I'm just going to dot in here roughly. This is what our circle looks like. This is not necessary, but it gives us a nice picture of our circle. Okay. Now, let's grab an arbitrary point on that circle. Let's say this guy right here. And let's say that it has coordinates x, y. X and y are unknown, but we just know that it has those coordinates. Okay, so now what we've got to do is find our equation. Well, let's take our center and discuss the distance to the center. Well, the distance out from our center to an arbitrary point, okay, this distance right here, we know that that's equal to 5 because it's the radius of the circle. So what does that mean? That means that 5 squared, the distance squared, should be equal to this guy squared and this guy squared. So let's talk about this guy down here first. Well, this guy, its length is the change in the x. It's delta x. Well, what is that? That's this point and this point, the difference in the x values. So we need to know how far over we go. Well, we know that this guy is x, and we know that this guy is 2. So if you remember, the delta x value is this guy minus this guy. So it'd be x minus 2. And then we want to square that because we're using the Pythagorean theorem. Now we got this part. Now the same thing's going to apply for the y's. So when we want to find this length right here, okay, its height value is y. Okay, this height value of this point right here, because we're trying to find this length right here, this height value is at a height of 6. And so the distance between those two is delta y, the change in y, which is y minus the value 6. So if we take this guy squared plus this guy squared, so this guy squared plus this guy squared, we get the diagonal squared, which is the radius. And so a little bit of algebra. It says 25 is equal to x minus 2 squared plus y minus 6 squared. Of course, we can change sides, no problem with that. And you can see where our solution comes from. Not too hard to do.